In this section, we will solve a couple of applications involving quadratic equations. First example, the length of a rectangle is 3 centimeters less than twice the width. If the area of the rectangle is 54 square centimeters, what is the length and width? So first, let's draw a rectangle so we know what we're looking at. Here's what we're told. We're told that the length of a rectangle is 3 centimeters less than. Now, whenever you're comparing something using the word than, the width becomes your base variable, which means we're going to let W equals to width and write the length in terms of the width, since we're saying the length of a rectangle is 3 centimeters less than twice the width. So the length is in terms of the width. So our width is going to be W. Now we're going to say that our length, this is equal to 3 centimeters less than twice the width. So we have twice the width, which is 2W, and 3 centimeters less than that, which is 2W minus 3. So our length is going to be 2W minus 3. Now we know that the area of the rectangle is 54 square centimeters. So we know that area is length times width. The area of a rectangle is a length times width. The length we know is 2W minus 3, and the width is W. And the area is 54 square centimeters. So we're going to say 54 equals to 2W minus 3 times W. Now to solve this quadratic equation, W over the right side, so we can get all the terms on one side. And remember, now we got to factor this. So let's make our x W squared is not equal to 1, it's 2. So we have to make our x factor. 2 times negative 54, that's going to be negative 108. And our is going to be negative 3. Now we need to find two numbers that multiply to be negative 108, add to be negative 3. Those are going to be negative 12 and positive 9. Negative 12 times 9 is negative 108. Negative 12 plus 9 is negative 3. Let's rewrite this quadratic. So we have 2W squared. With the negative 3W, we're going to split this up as negative 12W and positive. W 6. Common factor of W minus 6. So W minus 6. Now the zero product solve each of these equations, we get W equals to 6 or W equals to negative 2. Now, if this was just a problem we're solving without an application involved, both of these answers would be accurate. However, because we're talking about a length and a width, which are both of which are measurements, we can't have a negative measurement. So to say that the width is negative 9/2 doesn't make any sense. We can't measure something and have it be a negative width. So we're going to discard this answer. So our only valid answer is W equals to 6, which means width is equal to 6 centimeters. So on the side here, I'm going to say that the width is equal to 6 centimeters. Now the length is 2 times W minus 3. So the length is going to be 2 times W, which is 6, minus 3. This is going to be 12 minus 3, or 9. So the width is 6 centimeters, and the length is 9 centimeters. Don't forget to label the length and width, and don't forget to include the units. Now, if you multiply 9 times 6, it does give you 54. So this is how we know we did it accurately, since our area is 54 square centimeters. Okay, let's do one more example. Recall that the Pythagorean theorem states that in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. So in other words, a squared plus b squared equals to c squared, or the first leg squared plus second leg squared equals to the square of the hypotenuse. So a squared plus b squared plus c squared. Problem says one leg of a right triangle, so we know we have a right triangle. One leg is 1 centimeter less than the other leg. So if we let the second leg be x, the first one is 1 centimeter less than that, which is x minus 1. If the hypotenuse is 5 centimeters, find the length of each leg. Okay, so we're going to say that our first leg is x, which means we have x squared. Our second leg is x minus 1. This is x minus 1 squared. And our hypotenuse is 5, which is 5 squared. So let's see, we have a squared plus b squared equals to c squared. It doesn't matter which leg you label as a and b because you're going to add them anyway, but you have to be careful to label the hypotenuse 5 as the c value. Okay, the hypotenuse is always the c value. Let's simplify this. X squared is just x squared. X minus 1 squared is x minus 1 times x minus 1. 5 squared is 25. X minus 1 times x minus 1, x times x is x squared, x times negative 1, that's negative x, negative 1 times x is negative x, negative 1 times negative 1 is positive 1, equals to 25. Let's combine like terms, x squared plus x squared, that's 2x squared, negative 1x and negative 1x, that's negative 2x plus 1 equals 25. We move all the terms to one side to write this in standard form, so we have 2x squared minus 2x minus 24 equals to 0. Now we have to factor this quadratic. The first step to factoring any quadratic is to take out the greatest common factor. So between these three terms, the greatest common factor will be 2. This gives us 2 times the quantity x squared minus x minus 12 equals to 0. Since 2 is a constant, we can divide both sides by 2. So here the 2's will cancel. And what we're left with is x squared minus x minus 12. On the right side, 0 divided by anything is 0, so 0 divided by 2 will give us 0. When we factor this, we want to find two numbers that multiply to be negative 12, add up to be negative 1. That's x minus 4 times x plus 3. This is equal to 0. We don't need the x factor since the coefficient of x squared is 1. The zero product property tells us that either x minus 4 must be 0 or x plus 3 must be 0, which means x must be 4 or x must be negative 3. Now, if this was on an application, then these answers would be good. However, because it's an application and because x represents the length of a length cannot be negative, so we're going to discard the answer x equals to negative 3, and our only valid answer would be x equals to 4. So if x equals to 4, then the length of the first leg is 4 centimeters. The second leg is 1 centimeter shorter, so the length of the second leg, leg 2, is equal to 3 centimeters. And we can check our answer. We can say, does a squared plus b squared equal to c squared? So this is 9 plus 16, 5 squared is 25. 9 plus 16 is 25, and that is equal to 25, so we did it correctly. So the first leg is 4 centimeters, the second leg is one less than that, which is 3 centimeters.